1950, a physicist named Enrico Fermi was having lunch with some colleagues, talking about aliens when he stopped, looked around the table, and asked one simple question: where is everybody? That question, asked almost as a joke, turned into one of the most unsettling problems in modern science. Not because we haven't found aliens, because the math says we should have, overwhelmingly, and we haven't found a single one. Not a signal, not a probe, not a footprint, nothing. Today we're going through why that silence might be the scariest thing in the night sky. Let's do the math Fermi was doing in his head. The Milky Way has somewhere around 200 to 400 billion stars. Most of them have planets. We know that now, we've confirmed thousands. A meaningful fraction of those planets sit in the habitable zone, the not too hot, not too cold band where liquid water can exist. Even with brutally conservative numbers, that leaves millions of potentially habitable worlds in our galaxy alone. And our galaxy is one of an estimated 2 trillion in the observable universe. Now factor in time. The universe is 8 billion years old. Our sun is only about 6 billion years old, meaning there was already an 8 billion year head start for other stars, other planets, other civilizations, before Earth even existed. 8 billion years is enough time for a civilization to rise, colonize its galaxy, and vanish over and over again long before humans showed up. Even at sluggish, sublight speed travel, a single spacefaring civilization could spread across an entire galaxy in a few million years. That sounds like a lot, but on a cosmic timescale, a few million years is a rounding error. It should have happened already. Multiple times. So the numbers all point the same direction. The galaxy should be loud, full of signals, probes, structures, something. Instead, we get silence. Total uninterrupted silence. That gap between what the math predicts and what we actually observe is the Fermi Paradox. The most chilling explanation is called the Great Filter. The idea is simple. Somewhere between lifeless rock and galaxy-spanning civilization, there's a barrier. A step in the process that's almost impossible to get through. Something so improbable, so brutally hard to survive, that almost nothing makes it to the other side. And the entire question of the Fermi paradox comes down to one thing: where is that filter sitting, relative to us? If the filter is behind us, if it's something like the jump from simple single-celled life to complex life, or the specific accident that created a self-replicating molecule in the first place, then we're one of the lucky few who already made it through. The silence makes sense because almost nothing else got this far. That's the comforting version. But if the filter is ahead of us, still coming, that changes everything. That means the barrier isn't about starting life. It's about surviving intelligence. Every civilization that reaches our level of technology might run into the same wall. Nuclear weapons, engineered pandemics, runaway artificial intelligence, climate collapse, something that reliably ends technological civilizations before they can spread to the stars. Under that version, the silence isn't good news. It's a warning. It means everyone who got this far didn't make it further. We don't know which version is true, and we won't know until we either find someone else who made it through or we find out the hard way that we didn't. There's a darker possibility still, one that doesn't require civilizations to destroy themselves at all. It just requires them to be quiet on purpose. It's called the dark forest hypothesis, and the logic goes like this. Imagine the universe is a forest at night. Every civilization out there is a hunter, and every hunter has the same problem. You can't tell, from a distance, whether another hunter is friendly or dangerous. And in a universe this big, technology gaps between two civilizations could be enormous. A species only a few thousand years more advanced than us could be as far beyond us as we are beyond ants. So what's the safest move? If you're an advanced civilization and you detect a new signal, a new radio broadcast, a new intelligent species announcing itself to the galaxy, under the dark forest logic, the safest move is to stay silent, or worse, to eliminate the threat before it can grow into one. That means the entire galaxy could be full of intelligent life, all of it deliberately hiding, all of it listening, none of it broadcasting, which would explain the silence perfectly. We're not alone. We're just the only ones dumb enough to be shouting into the dark. Every time we send a message out into space, and we have some scientists consider that genuinely reckless. Not paranoid, reckless. There are gentler possibilities too. Maybe complex intelligent life really is astronomically rare, the rare Earth hypothesis. Maybe it takes an almost impossibly specific set of coincidences. The right kind of star, a large moon to stabilize our axial tilt, a Jupiter-sized planet sweeping up dangerous debris, plate tectonics, a molten core generating a magnetic field to block radiation. Stack up enough of those coincidences, and Earth stops looking typical. It starts looking like a fluke. Maybe civilizations don't expand outward at all. Maybe once you're advanced enough, physical colonization stops being interesting, and everyone retreats inward into simulation, into virtual worlds, into something we can't detect because it was never built to broadcast outward in the first place. Or maybe, and this one is almost funny, we're simply too early. The universe is still young by cosmic standards. Most of the stars that will ever exist haven't formed yet. It's possible intelligent life is not rare in space, but rare in time, and we just happen to be one of the first. None of these explanations rule the others out. They're not competing theories so much as a menu of increasingly uncomfortable options, and we currently have no way to know which one, if any, is correct. Here's why this isn't just a fun thought experiment. Every year, our own civilization edges closer to the exact kind of technology that could plausibly be a great filter. We've had nuclear weapons for 80 years and haven't used them again, so far. We're building artificial intelligence systems more powerful than we fully understand. We're altering our own climate at a pace with no real precedent. If the filter really is ahead of us, we are, right now, walking directly toward it, which means the Fermi paradox isn't really a question about them. It's a question about us, about whether we're the exception or just the next civilization to go quiet. So the next time you look up at a clear night sky, absolutely packed with stars, remember, every single one of those points of light is a place where, statistically, something intelligent probably should have happened. And as far as we can tell, nothing has. Maybe that's because we're early. Maybe it's because we're rare, or maybe it's because everyone who came before us learned the hard way to stay quiet. If you want to find out where this goes next, subscribe, because the deep end of this question gets a lot stranger from here.